Hello guys, welcome back to my channel. I'm Ishwardhan, studying in Sri Venkateswara College of Engineering from the department CSE Cyber Security. In this video, we are going to discuss about the structural representations and automata and complexity. Structural representation and automata. So in this presentation, we are going to study the fundamental concepts, models, and applications that shape our understanding of computation and complexity. Finite automata, the foundations of computation. It has two types, deterministic finite automata and non-deterministic finite automata. DFAs are mathematical models of computations that accept or reject strings of input symbols based on the deterministic transition function. A DFA is a finite state machine where for each state and input symbol there is exactly one transition to the next state. So at any point the machine has a single definite choice of transition. So the components of finite set automata are a finite set of states, a finite set of input symbols, a start state, a set of accept states or final states, etc. The characteristics of a finite state automata are only one path is followed for an input string, easier to implement and stimulate, requires more states for more languages. Next, non-deterministic finite automata. So non-deterministic finite automata allows for multiple possible transitions for a given state, making them more flexible than DFAs, but still equivalent in terms of computational power. An NFA is a finite state machine where, for a given state and input symbol, there may be multiple possible transitions, including transitions without consuming input, summation transitions. So, the machine can guess the correct path among the multiple options. The components of non-deterministic finite automata is same as DFA. So, multiple transitions for a same input in symbol, and the characteristics are multiple paths may be followed simultaneously for an input string, more flexible and often easier to construct, may require fewer states of some languages, can be converted to an equivalent DFA using the subset construction methods. Regular languages and regular expressions. So, the regular languages are a class of formal languages that can be recognized by finite automata. A formal language in the theory of computation is a set of strings composed of symbols from the finite alphabet and follow specific systematic rules. So they are defined by regular expressions, which are patterns used to match strings. Then, pattern matching regular expressions are widely used in programming languages, text editors, and other tools for searching, filtering, and manipulating the text. So, formal languages are categorized into many types, in which the regular languages are generated by regular expressions or recognized by finite automata. Next is transition functions and transition state diagrams. So the transition functions maps a state of and an input symbol to the new state, defining the behavior of the automation. So the transition functions defines the rules of movement of the automation. It specifies the state based on the current state and the input symbol. Next, the transition state diagrams provide a visual representation of the transition functions, making it easier to understand the logic of the automations. So, the transition state diagram is a graphical representation of the transition functions. It uses circles to represent states, arrows to represent the transition between the states, or labels on arrows indicates the input symbols that triggers the transition start states, denoted by an arrow pointing it to the without a source, and the final state represented by double circles. Equivalence of DFAs and NFAs. So the equivalence theorem states that any language recognizable by an NFA can also be recognized by a DFA and vice versa. Computational power, while NFAs offer greater flexibility, DFAs are more efficient in terms of implementation and analysis. The equivalence theorem provides a bridge between these two models. The equivalence of DFA, that is deterministic finite automata and non-deterministic finite automata, lies in the fact that both recognize the same class of language, regular languages. Although their structure and behavior differs, any NFA can be converted into equivalent DFA. Minimization of finite automata. In this, we have state minimization and optimization. Minimizing a DFA involves reducing the number of states while preserving its behavior, resulting in more efficient and compact representation. Optimization minimization techniques are used to improve the efficiency and performance of the automation based algorithms perfectly in areas like compiler designs and pattern recognitions. Next, push down automata and context free languages. Pushdown automatas extends DFAs by adding a stack allowing them to recognize a wider class of languages known as context-free languages. So pushdown automata is a type of automation that extends finite automata by incorporating a stack. The stack provides additional memory enabling the PDA to recognize the context-free patterns. And the context free languages, that is, these languages are defined by context free grammars which allows for recursive rules and relationship between the symbols. Turing machine and computability. Turing machines are universal models of computation that can stimulate any other computers providing that they can solve any problem that algorithmically solvable. computable theory Computability theory investigates the limits of what can be computed, demonstrating that there are problems that cannot be resolved by the Turing machine. And the P and NP problem, complexity classes and implications. P class problems in P can be solved in polynomial time, meaning the required to solve them grow proportionally to the polynomial function of the input size. NP class problems in NP can be verified by polynomial time, but finding a solution may require exponential time. The P versus NP problem asks whether these two classes are equivalent implications. The P versus NP problems is one of the most important open problems in the computer science with significant implications of cryptography, optimization, and artificial intelligence. Thank you.